Hey class, this video covers the requested problems from the Jamboard. So one of the post-it notes was for problem 2, A through D. So in order to answer this question, to look for the exact values, you need to know your special triangles, because anytime you find alpha, which we're going to do in this problem, alpha being the reference angle, it will always turn out to be either one of the quadrantal angles, like 180, or your alpha will be 30, 45, or 60. So you need to know the sides of these triangles. The 30, and if you look on your paper plate, you'll see this goes long side, short side. So this side is the radical 3/2, and this side is the 1/2. This green triangle is the same triangle, it's just that it goes short side, long side, so that's the 1/2. And the y side is the radical 3/2. And on the 45, 45, 90, both the x and the y are radical 2/2 and radical 2/2. So it's the side that has both sides the same, has both the 2's, and it has two sides the same, has the 2's. Okay, so the way we want to do this is we also need to know the quadrantal angles. So right over here on this point at 0 degrees, we've gone right 1 up 0. At 90, we have 0, 1. At 180 or pi, we have -1, 0. And here at 270, we have 0, -1. And of course, those are all your xy coordinates. And these all on this side are x, and on this side are your y values. Okay, 180 is a quadrantal angle, and 180 is here. So we're talking about this x and y. And also, all of these problems that have to do with exact values on the unit circle, your r value is equal to 1. And then you also need to know, to solve these problems, that sine of theta is y over r, and cosine of theta is x over r, and tangent of theta is the y over the x. And then you need to know that sine goes with cosecant, and that would be r over y then. Cosine goes with secant, and that is r over x. And that tangent goes with cotangent, and that would be the x over y. And then the last thing you need to know is not only how to find alpha, but everything about the signs in these quadrants, that all of them are positive in this quadrant. And then in quadrant 2, it is the sine and the cosecant that are positive. All squirrels tickle. This one's tan, cotan, chipmunks, that is cosine, and secant. And then in quadrant 1, alpha is theta. Quadrant 2, alpha is 180 or pi minus theta. And in quadrant 3, alpha is theta minus 180 or pi. And quadrant 4, alpha is 360 or 2 pi minus the theta. All right, I feel like that was like a mini lesson of several lessons all in one, and we haven't even started the problem yet. Cosine 180, that's this right here. So we are going to know that cosine is x over r. Because it's quadrantal, I don't have to do any of the quadrant things of figuring out any SIGNs. Those will work itself out with the coordinates. So our x value is -1, our r value is 1, and that simplifies to -1. All right, B, 135. So I'm going to do B over here, the sine of 135. All right, first thing to ask yourself is, do I need a coterminal angle? Is my angle that's given, is my theta between 0 and 360 or 0 and 2 pi? And it is. If it wasn't, if it was less than 0, I'd have to keep adding 360 until I got it above 0. If it was greater than 360, I'd have to keep subtracting 360 to get it below or equal to 360. So we're good. I don't need a coterminal angle. And I need to figure out what quadrant 135 in. That's 2. From the all squirrels tickle chipmunks in quadrant 2, I know that sine is positive. I find alpha by doing the 180 minus the 135. 135. And so I get alpha is equal to 45 degrees. All right, so I'm going to evaluate the sine of 45 degrees. And it's positive, so I'm going to do the positive y value of y over r. All right, and I have to look at the 45 triangle because that's what alpha is. Well, y is radical 2/2, and r is 1, so my answer is radical 2/2. All right, radical 2/2. If this had been negative over here, or over here, then I would put a negative in front of the answer. All right, so let's do C. C is the cotangent of 225. All right, I don't need a coterminal angle. I'm in quadrant 3. I do all squirrels tickle. I know it's positive because cotangent and tan go together. My alpha is 225 minus 180. So my alpha is 45 degrees again. So I'm going to look at this 45 triangle, and cotangent from over here we know is x over y. So I'm going to do the positive x over y for the 45-degree triangle. Well, that is radical 2 over 2 over radical 2 over 2. And anything divided by itself is, of course, 1. So the answer to this one is 1. One more to go. D, cosine of 210 degrees. Okay, I don't need a coterminal angle. We're in quadrant 2. No, we're not. We're in quadrant 3. We're in quadrant 3. We've gone greater than 180. Sorry about that. Quadrant 3. All squirrels tickle. All right, tangent's positive in this quadrant, which means cosine's not, because cosine's positive here, and all squirrels tickle and here. So in quadrant 3, cosine is negative. So I need to find alpha now. Alpha is 210. Subtract the 180. My alpha is 30. So I will evaluate the negative cosine of 30 degrees. Well, cosine is x over r, so I'm going to do the opposite of x over r for the 30-degree triangle. Well, here's my x, and r is 1, so I'm going to do a negative radical 3 over 2 all over 1, and anything over 1 is itself, so my answer is negative radical 3 over 2. Negative radical 3 over 2. All right, so whoever asked that question, there you go. I hope that helped. All right, moving on. Somebody had asked for all of the word problems starting at 31, and somebody else had asked for 33 to 39. So I'm just going to do it all in this one segment. Okay, so I have a submersible or a submarine traveling at a depth of 250 feet. All right, so here's the surface of the water. Okay, and then I'm already 250 feet down. So I'm even with this surface. Okay, so here's my submarine. I don't know. I have no idea what a sub looks like. It looks more like a whale. But anyway, we are diving at an angle of 15 degrees with respect to a line parallel to the water surface. Here's my line that's parallel to the water surface. Okay, so I'm going to dive at a 15-degree angle relative to that line. So that's 15 degrees. It travels a horizontal distance. Well, that's this distance, not the distance it traveled, but if I went from where you started horizontally and I look for the submarine underneath, that I would have traveled a distance of 1,500 feet. So we want to know what is the depth of this thing after the dive. So I'm going to solve for this side y, and then my answer will be y plus 250 feet. Okay, so relative to the 15, I have opposite and adjacent. So opposite and adjacent, right? That's a tangent problem. Tangent is opposite over adjacent. So I have then that the tangent of 15 degrees is the opposite, which is y, over the adjacent, which is 1,500. Multiplying both sides by 1,500, I have y is equal to 1,500 times the tangent of 15. You want to make sure your calculator's in not radian mode. You want it in degree mode. So if you see radian mode, you want to take it out of that. You want it in degree mode. I'm going to just put a little star. Degree mode. Let's put mode. Okay, so if I solve this out, I get y is equal to 401.924. And I did not tell you what to round to, so you might have rounded to the nearest integer. You might have rounded 2 places. That's okay. I will try to remember to be more specific on the test, and if I don't, then you choose. Okay, so my answer then is that plus the 250. So my total depth comes out to be 600 and what do I have? 50, 250, so 651.924 feet. All right, so I think the hardest part was drawing the picture, most likely. Okay, fire department longest ladder. They can use it for up to 110 feet off the ground. That's vertically off the ground. What's the safe angle of elevation? Angle of elevation. Angle of elevation is respect to the horizontal and your line of you're looking up at something. That's your angle of elevation right there. Angle of elevation. It's always with respect to your line of sight and the horizontal. So they have a ladder leaning up. There's your ladder, right? Leaning up against some building. And it comes out that far away. All right, so the ladder itself is 110 feet. They can use it for rescues up to 100 feet off the ground. So from here to here is 100 feet. I want to know this angle. So again, I have tangent. Well, do I have tangent? No, I don't. I have sine, right? Because I have the opposite over the hypotenuse. Sorry about that. Sine is opposite over the hypotenuse. This side's the adjacent. We don't need that side. And we know that this is the hypotenuse because it's opposite the 90. All right, so the sine of the angle is the opposite, which is 100, over the hypotenuse, which is 110. So then theta is the inverse sine. Whenever we want an angle, we do the inverse sine of the 100 divided by the 110. So do that out in your calculator. Remember to use that second sine button. You get 65.380 degrees. And again, you might have rounded differently. That's fine. I didn't tell you. So that would be the maximum angle right there in order to get up to 100 feet. Okay, so we have two brothers. They bought a tent, so I'm going to draw my tent. That is not a 90-degree angle, so I can't use SOHCAHTOA because SOHCAHTOA is only good for 90-degree triangles, for right triangles. This is a center pole that is 6.25 feet high. The tent sides, these are the sides of the tent, they make an angle of 50 degrees with the ground. There's 50. I would like to know this whole distance, the width of the tent, but I'm going to temporarily only deal with this triangle here because that's a right angle. So I'm going to put this as x, and my answer is 2 times x, or x plus x. But right now I'm going to find half the width of the tent. And so if I do that, relative to this angle, I have opposite over adjacent. That's why I said tangent before on the previous problem. I was looking to the next problem on my page. Sorry about that. So tangent of 50 is the right tangent is opposite over adjacent. Tangent of 50 is the opposite, which is 6.25 over the adjacent, which is x. Now, whenever you have x in the denominator or your variable in the denominator, you can swap on the diagonal, right? I can swap those two. So I end up with x is equal to 6.25 over the tangent of 50. And the reason you can do that is as long as your cross products stay the same, it's called the means extremes product theorem. You can rearrange things as long as your multiplications on the diagonal or your cross products stay the same. And I have 6.25 times 1. I still have that here. And I have the x times the tan 50. I still have that as a cross product here. So now I just put that in my calculator, and I get that x is 5.244 feet. So 2x, which is the answer, is then 10.489 feet. You might have rounded differently if you just doubled this answer. I left all the extra decimals on there before, and I didn't round it all, and I just said times 2. So our decimal places might be off by a slight amount, and that's okay. All right, 34. All right, this one looks really tricky, but you really just have to not overthink it. If you look at your unit circle, on your paper plate circle, you have, instead of 56 here, you have a 1. And if we forget all about all of this extra stuff, we don't look at it at all, and we consider this a 1. It looks really familiar, like your special rate triangle, right? This would be the point 1 comma 0. This would be 0 0 on your plate right there. This would be 1 0. This is your 30-degree triangle, and it is your long side, short side. So that's your radical 3 over 2 1/2. This is the 45 would be here. We don't care about that one. This is the 60, which is the same as this triangle, just flipped. So this is short side, long side. This coordinate would be 1/2 radical 3 over 2. And then up here we have 0 comma 1. So if I just said you had a radius of 1 here, or a distance from here to here, right? R is 1, you'd be able to do this. Well, now all we're doing is um, we're changing the radius to something else. That's all we're doing. I don't know how to go to full screen right away. There we go. All right, so we're just changing it. Now we're saying instead of this triangle having this as a 1, I'm just going to do this triangle right here for reference. If that was 1 and this was radical 3 over 2 and this is 1/2, now I'm saying make it a really big triangle because this is 56 now, or 56 times the one we had over there, which means this side is 56 times the 1/2, and this side here is 56 times radical 3 over 2. Well, if I do that, then this side is 56, which makes sense. That's the radius. This side is 28, and this side is 28 radical 3, which makes this point here now the x1, y1. That is equal to 28 radical 3, comma 28. And the x2, y2 are just we're just going to switch x and y. This one's 28, and this one's 28 radical 3. But it's okay. It's good stuff. All right. All of these car wheel problems, the amount, when you have a wheel, the amount when it's rolling, when you roll that forward, the distance that it travels is equal to the circumference of the wheel. And circumference is 2 times pi times r. Now, they gave us the diameter is equal to 34 inches. Well, radius is half the diameter, so the radius is 17 inches. Okay, so we want to know how far will it travel if we do 20,000 of those. If I just find the circumference and multiply by 20,000, I would have my answer in inches. But the question is how far in miles. So this is just a unit conversion problem. It's really taking my circumference, multiplying it by 20,000, and then converting the units. I'm going to use dimensional analysis to do it, just like in science. So I'm going to say then that my circumference, let's figure out my circumference is now 2 times pi times 17, or my circumference is 34 pi inches. All right, so my travel distance, my distance that I'm looking for, is equal to, we do 34 pi inches per each revolution. We are now going times 20,000 revolutions. I'm just going to put that over 1. And now the revolutions cancel. So you can see here, I now have inches. Let's go to feet. If I want feet, I need feet on top and inches on the bottom so that my inches can cancel. Well, there are 12 inches in 1 foot. Now my units are in feet. Inches are gone. Now I want to go to miles. Well, I want miles, so miles will have to be on top and feet will have to be on the bottom so that my feet can cancel. I have 5,280 feet for each mile. So the math is just taking on top, we have 34 times pi times 20,000. On the denominator, make sure you use parentheses. I have 12 times 5,000 280. It is really critical that you have the parentheses around your denominator, or your calculator is going to think that you're multiplying the top, you're dividing by the 12, and then if you don't have it in parentheses, it'll take an answer for that and then multiply by 5,280, and that would be incorrect. And of course, this is now in miles. Our distance here, it said round to 3 places. I had 33.717 miles. Okay, 2 more to go. I'm on it. Okay, this is nothing more than saying, if I said find the area of this circle, you could do it. If I gave you, if I said the outer radius, I'm going to use a capital R. If I said the outer radius was 30 inches, you could find that area, right? And then if I said, here's another circle on the inside, and I said the inner radius, and I'm going to use a little r, is equal to 8 inches, you'd be able to find those two area problems, right? Because the area of a circle is pi r squared. So that would be quite simple. And then if I said take the outer and subtract the inner, you would end up with the area of the donut, right? But now I'm taking it one step further because I don't know how to get out of this. I want to get a different color pen. I'm taking it one step further because instead of the whole donut, I'm just taking, like, that's your windshield, and I want the area of this shaded here. So it's really saying take the outer sector area and subtract the inner sector area. Okay, so the outer sector area, we're in degrees. So our sector area formula is the one we just used on the previous slide. We had theta over 360 times pi times r squared. So our outer sector area is 120 over 360 times pi times 30 squared. We're going to subtract our inner, which is still 120 over 360 times pi times 8 squared. That's an 8. And that will equal the shaded area. Well, I'm going to factor out, they both have 120 over 360 and pi. So I'm going to say the area of the shaded is equal to 120 pi over 360, because our degrees cancel. And we're going to have 30 squared minus 8 squared. And you have to do 30 squared minus 8 squared. You can't do 30 minus 8 and then square it. That will not work. And our answer, since we are in inches here and we're dealing with area, our area will be inches squared. So I think I said round to 3 places. If I was doing this in my calculator, I would do this part first or use parentheses. It's up to you. The last thing I would do would be the division, but you see what works best for you. I'm getting 875.457 inches squared. All right, one more. You've seen this problem as a cow. I think you've seen it as I don't even know what else. We've had a variety of things. I think we had a bearded dragon. Now we have a tortoise. Okay, so the key to these is recognizing these right angles. So you're really just traveling these quarter circles. There's a quarter circle. So you could find the area of that. And the area of one there would be 90 degrees over 360 degrees times pi times the 75 squared. All right, so far so good. Let's go to the next one. Let's get a different pen here. Go back to the full screen. Okay, let's do this down here. Now, this 75-foot leash that came out to here, we're going to lose 45 feet off of it, right? So if I take 75 minus 45, I'm going to have that this radius here from here to here is now 30 feet. And that can go a quarter circle like this. And here's that 90-degree angle again. So the area of this second part is the 90 over 360 times pi times 30 squared. Okay, we're getting there. Different color. Let's go with purple. Okay. View full screen. Okay, we can't go any further here because 30 is less than 40, so we hit the wall right here. So we're done going in this direction. Let's go back up and see if we can go in this direction. We had 75-foot leash, right? From here to here, 75. We lose 40 feet here. So I now have this piece here is 35 feet right there. So I can do this quarter circle out until I'm even with the wall, because then I lose some of my leash. Okay, so this part, let's call that one 3. The area of 3 is now the 90 over 360, and it's always 90 because I have these right angles. 90 over 360 times pi times 35 squared. All right, I have 35 feet, my wall is 20, so I can still keep going. I lose 20 feet of my 35 feet, and this is 15 feet then. And I can go down. Now 15 is definitely the last I can do because this wall was 40 and that was 40, so this whole wall is 80 over here. Here's my 90. Oh, I need a different color, don't I, to be consistent here. Let's go with, oh, I don't know, pink. And let's make it thin. All right, let's go back to the screen and we'll wrap things up. Okay, so the area, we have 15 here, and we have that 90-degree angle, and we're going to call that 4, the area of 4. So that's 90 over 360 again, times pi, but now it's times 15 squared. So we need to wrap it up. The area total here, hopefully you can see this pink. It's kind of light, but okay, so the area total would be, I would take that, add that, add that, and add that. I'm recognizing the 90 over 360 times pi is something I could factor out. And I'm also recognizing that 90 over 360 is equal to 1/4. So I'm going to write that my area total is 1/4 and the pi. That's what I'm factoring out, right? This is 1/4 pi. And I can do the 75 squared plus the 30 squared, plus the 35 squared, plus the 15 squared, and just simplify it. That beats having to round here, round there, round there, round there. Now I round once at the end, and my area is 6,263.550. Since this was in feet and its area, we will do feet squared. And we are done. I think one of the most important things you can do to study for this test would be to know these area formulas and arc length formulas. You definitely need to know SOHCAHTOA, and you need to know these special triangles here. You definitely need to know those side lengths. You don't need to know all the way around the triangle. You just need to know the ones from quadrant 1, and then you need to know this stuff for sure. All right, good luck studying. You should study outside. It looks beautiful. Well, at least it is today while I'm making this video. Thanks for coming to watch it.